You know, for years, the battery world has been all about one thing, lithium-ion, right? It powers our phones, our cars, pretty much our entire modern lives. But that era, the reign of a single king, is coming to an end. 2026 is the year the whole story of energy storage just gets way more interesting, and we're going to break down exactly how.
And I mean, just think about it for a second. From keeping our power grid stable during a heat wave to powering the next generation of EVs and smart tech, batteries are the absolute engine of progress now. They're not just some accessory anymore. They're the foundation of everything we're building.
And that's the big question, isn't it? As our needs for energy get bigger, more demanding, more complex, we're starting to push the limits of that one go-to engine. Look, lithium-ion is incredible, don't get me wrong, but its supply chain is tricky, its costs can be all over the place, and for the really, really massive jobs our future depends on, it's just not always the right tool.
So, instead of trying to force one tool to do every single job, 2026 is all about opening a brand new toolbox. For decades, lithium-ion has been our amazing Swiss Army knife, fantastic for a huge range of things. But now, we're grabbing the specialized instruments, the heavy-duty gear for the really big, tough jobs.
Okay, let's start with the biggest job there is, our electric grid. I mean, the challenge of storing massive amounts of solar and wind power so we can use it when the sun isn't shining or the wind isn't blowing, that is one of the biggest engineering puzzles of our time. And this is not a job for a pocket knife. This job needs a sledgehammer.
So say hello to our first heavy-duty tool, sodium-ion. It's not flashy, it's not trying to be the smallest or the lightest. It is a pure workhorse, built for three things: to be ridiculously cheap, to be fundamentally safe, and to be made from materials that are unbelievably abundant. It's the sturdy, reliable power the grid has been desperate for.
Okay, now this table is so important because it forces us to think differently. Your eyes might go right to energy density and see that sodium-ion is lower. And for your phone or your car, that's a big deal. But for a giant battery installation sitting out in a field, who cares if it's heavier? What you do care about is that the raw material, sodium, basically salt, is 1,000 times more common than lithium. And look at safety. You can ship these things at 0% charge. That is a massive game changer for logistics and safety on these huge projects.
So, how does this thing actually work? Well, if you get the basic idea of a lithium-ion battery, you're already 99% of the way there. Seriously, it's the same exact principle. Ions moving from one side to the other and back again. We're just swapping out the rare, expensive lithium for common, dirt-cheap sodium. It's a simple switch, but with absolutely profound consequences.
And here is the biggest consequence of all. It all comes down to cost. This chart says everything. Sodium-ion is already getting competitive, but as the factories scale up, the projections show it becoming so much cheaper. Getting down to $40 per kilowatt hour, that doesn't just make renewable energy cheaper, it fundamentally changes the entire economic model of our power grid.
But what if you need power for more than just a few hours? What if you need it for a few days? Well, you grab another tool from the toolbox, the iron-air battery. This technology is so cool. It basically breathes. It oxidizes or rusts iron pellets to release energy, and then it uses electricity to reverse the process. This is the key to getting through a multi-day blackout or a week-long stretch with no wind.
And let's grab one more heavy hitter for the grid: flow batteries. Now, the genius here is that the energy isn't stored inside the main device itself, but in these huge external tanks of liquid electrolyte. This means you can scale power and capacity completely separately. Need more hours of backup? Just add a bigger tank. Need more juice right now? Just add another power stack. It's the ultimate in customizable, long-term grid storage. Okay, so we've seen the heavy-duty power tools for the grid. Now let's swing to the complete other end of the spectrum. Let's talk about the precision instruments, the high-performance tech designed to make our personal gadgets and our cars faster, smaller, and way more powerful.
The first number you need to know is 400 watt-hours per kilogram. That's just a fancy way of saying how much energy you can cram into a certain amount of weight. And let me tell you, 400 is a massive, massive leap over what we have today. This means way longer range for EVs and way more power in a much smaller, lighter package. And the second number? 5, as in 5 minutes. A full charge, 0 to 100% in the time it takes to, grab a coffee. This isn't some lab experiment. This is the performance of a technology that is actually shipping in products this year.
So what is this magic? It's the solid-state battery. The big breakthrough here is getting rid of the flammable liquid that's inside a normal battery and replacing it with a stable, solid material. That one change is what unlocks this insane performance, and it makes the batteries fundamentally safer. In 2026, you can already find it in high-end electric motorcycles, making them faster, lighter, and safer.
But hey, we're not just inventing brand new tools, we're also making our old ones way better. Silicon anode tech is the perfect example. It's not a whole new battery chemistry, it's a super powerful upgrade to our trusty lithium-ion multi-tool. By swapping out the standard graphite part for silicon, it can suddenly hold way more ions. We're talking about 20% more juice in the exact same physical space. This is a huge reason why flagship phones are suddenly getting much better battery life.
So we have these amazing heavy-duty tools for the grid, and we have these super high-performance precision tools for our devices. But the real revolution, the thing that makes 2026 so special, is that all these tools are finally starting to talk to each other. They're starting to work together as one big intelligent system.
And this is where it just gets mind-bendingly cool. Your EV, with its high-density battery, is no longer just a car. With vehicle-to-grid, or V2G, it's now a mobile power station that can run your house during a blackout. And when you network thousands of EVs and home batteries together into what's called a virtual power plant, they can act like one gigantic, city-sized battery to keep the lights on for everybody.
So when you pull back and you look at this whole picture, the biggest takeaway isn't that one battery is winning or another is losing. It's that we are finally moving beyond a one-size-fits-all world. We're entering an era of a multi-chemistry future.
And this quote just says it perfectly. New tech, like sodium-ion, isn't here to kill off lithium-ion. It's here to take on the heavy lifting jobs that lithium-ion was never the perfect fit for. And that frees up lithium-ion to get even better at what it does best, powering our high-performance tech. And that brings us right back to our main idea. The future of energy is not about finding one single magical battery. It's about building out a diverse, flexible, and powerful toolbox, and having the smarts to pick the right tool for the right job every single time.
This explosion in our energy capabilities is honestly one of the most exciting things happening in the world right now. It's a fundamental shift that's going to enable all sorts of new technologies and reshape our world. So the real question we're left with is, now that we have this incredible new toolbox, what are we going to build?